Yeah, thanks a lot, Nishant. So as Nishant said, like there are reasons to hate embedded development, and one of the main reasons I initially really not enjoyed it was that I had to touch my board constantly, and it was for various reasons, like removing the SD card to flash it, like putting it into a SD card machine, and changing the boot mode pins, or removing a peripheral like display or camera. Or sometimes the board is just stuck and you have to reset it, and like a normal reboot command doesn't work, it's stuck, so you have to physically either unplug the power cable or hit the soft reset button on the board. So it basically makes you switch away from the keyboard and monitor and make you lose the flow state if you're developing or like in a quick debug build test cycle while working on the kernel or U-boot or anything else. And it also makes working remotely a pain because you need to call up somebody in the office to, let's say, reset your board or something like that. So out of all these common reasons that force us to be hands-on, most of them actually can be solved very easily. And I've seen a lot of people over the past 2 years that I've been at TI actually gradually pick these things, but not all of the things that I'll be mentioning today. So I think it might be useful to folks who are using one of the things, but not the other. And in general, I see whenever some new joinee or some new intern comes, it takes them a couple of months of painful, all of these like SD card reinsertion for every time they're flashing a kernel before they finally give up and ask for some better way to do that. So yeah, let's move forward. So the simplest thing that you can do is just use some power toggling mechanism. Usually that's a relay. There have been fidgets that were around in the TI India office, but those were hard to ship and rare. So we found these two alternatives that everybody is using in the Bangalore office at least. One of them is USB relay. So this is a very cheap and easily available relay board with just a microcontroller and USB-B type connector, and you can just plug and play. And simple like this GitHub repo, if you clone, you can build it, or the package is even present in Debian and Ubuntu repositories. So all you need is to run a single command, and you can basically turn on and off any electrical signal. That's what I saw. But one catch here is that if you're toggling AC power, we've noticed in the office that the relays go bad within a couple of months, even though they're rated for AC. So I just cut up my USB-C cable, and with that, it's running fine for now, almost 1.5 years. Never faced a problem. But if you do have more budget to spare, or you want something more reliable, there's also this Ethernet relay that a few folks are using. And this just, I think you can just like send some IP packets, and I'm not sure how it works, but it's fairly straightforward again. And this is robust even when toggling AC. I think Kamlesh has been using it for quite a few months now and never faced a problem with toggling AC power. So with this, you don't have to at least unplug and plug the power cable again if you have to hard reset the board. Next up, we have UMS. So a common thing that I notice is people just remove the SD card from the board and plug it to their PC to flash, let's say, kernel or update some images on their file system or update the U-boot. But you can actually make the board itself an SD card reader. So if you have U-boot up on your board, most likely it is already built, like all the default def configs we have in our U-boot builds already enable this UMS command. So UMS is USB mass storage is the USB specification for the class where it's used for various pen drives or SD card readers. Like all of them basically give a mass storage device over a standard interface over the USB port. And the USB port that is there on our boards, especially the DRU, like dual role USB port on the Citara or the SKs, they can function, they can basically act as a slave device and function as a SD card reader, a UMS device to the PC. So all you need to do is just plug in the USB cable from the board to your PC, and go into U-boot and run these two commands to see what happens. So if you have an SD card inserted, it's usually MMC1 on Sitara boards. So you just run UMS0. 0 is the USB interface, which is 0, and MMC1, which is the MMC interface, and you'll see that USB device pops up. And similarly for eMMC, if you have something flashed over there and you want to mount it on your PC, you can do it same way. So this wouldn't even be possible without UMS because you cannot pull that chip out and plug into your PC. So let me just quickly show. I'll give the brief demos while we're doing the presentation. So let me just, so I'll give a demo of this USB relay that I have. So in the first port of the USB relay, my AM628 board is connected. So I just run this command. Let me so USB relay, the relay name, and then sleep, and then the relay name again. So I have it set on default on. Like in the relay, you can choose whether you want it to, when the relay is not activated and the electromagnet is not active and not pulling the switch to one direction, what is the default state? So my default state is connected, which helps because I mostly want to keep my board on and only want to reset it a few times. This helps elongate the life of the relay. So what I do here is I just set it to 1, which will activate the relay and turn off the power to my board and sleep for 1 second, and then do relay equal to 0, which will deactivate it and turn it back on. So once I do it, it's done. But as you can see on the left window, nothing appeared on my board yet because I'm in DFU boot mode. We'll cover that later. But let's just say it was plugged into SD card, so you would see immediately the board was hard reset, and then you would boot to U-boot prompt. And once we get to U-boot prompt, so once you get to the U-boot prompt, you can run UMS0 and MMC1. And as you can see, this command ran successfully. And now if I go back to my PC and do lsplk, I see that this dev SDA device is present now. And I can even mount LSPA to some mount point. I have to specify the partition, LPA2. As you can see, my rootfs on my SD card is mounted. And if I just unmount it now and Control-C this UMS command, you can see that it's gone now. So that's how simple UMS is. All you need to do is run a single command and you can turn your board into a SD card reader. But a problem here is, what if while flashing my SD card and I'm using SD card as my main device to boot the board, I break my U-boot. So now I'm stuck. Now I again have to go to the office and plug in my SD card to a normal card reader and fix the U-boot binaries. So we'll come to that later. But let's go to the other problem we had of changing boot pins. So it's very annoying to, first of all, find a pin to flip the switches on the board, or that pin sometimes falls and gets stuck under people's shoes. That's happened to me twice in 2 years. It's overall a very annoying process, and if we could automate that, that would be good. So you can basically use the force and never have to touch your board to change the boot pins, because we have a register in our wake up control MMR region, which basically sets the boot mode. And what the pins physically on the board are doing is, I think, just modifying this register. So if you don't hard reset your board, you can just change this register and just do a soft reset, and the board will boot, board will reset into a state as if the boot pins were set to the mode that you set this register to. So for AM62 family, this register is at this particular address. I think for the CentOS also it's same, but there might be one another register you have to modify. But basically, these are the values you can set for the various boot modes. You can find these in TRM as well, but it's slightly hard to translate. So I've just listed them here in case somebody wants to mess around. And then all you need to do is use the memory write command in U-boot, which is MW. So memory write.word, because we want to write a word, and just give the address and give the boot mode. and then do a reset command, which will soft reset the board. So with this, like let's say if you were in SD card mode and you were working remotely and you wanted to boot off of eMMC, you could just boot into U-boot, do this command, reset, and your board will reset into eMMC, starting from the ROM itself. So same problem here though. What if the main boot mode that is set on my board, I somehow accidentally break my U-boot binaries and my U-boot is not reaching the prompt again. So I still have to physically go and fix it. So that's where the next thing comes in, which is DFU. So DFU is basically a very common, one of the common ways that are used to upgrade firmware. It's even there on your iPhone probably. So it's a standard specification again from USB. And what it does is if you put the device in a mode where it is active for DFU and you plug it into some PC, the device will broadcast that I can accept a new version of a firmware for, let's say, a bootloader, or let's say some other like firmware that you want to update. And you basically just run a command, and over the USB that firmware is delivered and flashed to the device. So our K3 architecture's ROM by default accepts the bootloader binary, the first stage bootloader over this DFU protocol. So all you need to do is have that USB cable that we were talking about before, which you could use for UMS. The same USB port would be used for DFU as well. And just set the boot pins to the DFU mode. I've shown the pins for the AM62A board in this image, but you can probably look up the TRM for Jacinto boards. The pins are seen for all the AM62 family of SK boards. So all you need to do is set the boot pins to DFU mode. And then if you run this DFU util -L command, and you'll see that it's enumerating your board and some targets that you can flash to. And then you can just simply flash your tiboot3.bin binary using the second command. So let me just give a demo before I talk more about this. So let's say I reset my board again using this USB relay commands that we had. And now if I do sudo DFU util -L, you can see that it shows two DFU instances. One of them is called SOC ID and one of them is called bootloader. So these are basically the two endpoints this entity has, and you can either download a bootloader binary, which would be tiboot3.bin, to the second one, or you can upload something from the board to your host, which is the SOC ID. So let's say you want to see which SOC is actually running and some like hard-coded data that the ROM can send to you on the host. You can use the SOC ID feature. So we'll use both actually. So if you do this sudo DFU util -R -A SOC ID and -U, which is for upload, and save it to a file. Let me delete this file. I was testing this before. So yeah, if you run this command, it will wait. Sudo rm. Yep. So now the upload is done. The terminology is confusing. Upload means from the board to your host, and download is vice versa. So now if we just look at this SOC ID file, you can see it has a bunch of metadata. But what is relevant to me personally is that I'm talking to the AM62A board and its HSFS and some other stuff that I haven't deciphered yet. And similarly, now basically you can see on the left of my screen that the UART is completely unresponsive because we've changed the boot mode. So it's not reading SD card, not reading anything. So if we want to now boot the board, we have to give the first tiboot3.bin binary from our host over this DFU. So you could use the this command. So DFU util -R -A is the same as before. Bootloader is the target that we saw in the list earlier. And tiboot3.bin is the binary that we have. So once I do this, you can see that the R5 SPL logs come up. So it has successfully booted the first stage bootloader. But now the question is, how do we go ahead and boot the second stage bootloader, which could be A53 SPL or U-boot image or a Linux kernel. So how we've set up our U-boot R5 binary is that now it acts like the DFU host. And if you run sudo DFU util again, you'll see that the targets have now changed. You have two targets now, tispl.bin and uboot.image. So we could just go through the normal flow and one by one flash both of these binaries as well. So let's do tispl.bin. As you can see, this guy downloaded that and printed the logs for A53 SPL, and then you could do U-boot image as well. So now we have the U-boot prompt, and this could be done without any SD card plugged in, nothing on my flash, nothing on my eMMC. It's just my board and my PC and a USB cable. So you can always reach a functional U-boot prompt without having anything flashed on your board permanently, which is good for recovering and working remotely. So I could even run UMS now and it will just work. So I can flash my SD card even if my SD card is completely corrupt and have to flash it from scratch. And yeah, that was it on DFU. And now, yeah, good question. How do you build these binaries that I just flashed? So the default binary, default tiboot3.bin that we ship in our SDK is actually not compliant. Like the first binary you'll be able to flash, but it won't create these DFU devices for the second and third stage bootloaders. So you have to basically go to U-boot, and when you basically compile U-boot, you would run some make commands and you would pass a def config. So there are two versions of the def configs for at least all the Citara boards that I've seen. One is the standard one that we use and ship in our SDK, and the other one has USB DFU in between. So 168 DFU. So this is the def config that you use to build your R5 firmware when you want this DFU full boot mode. And actually, I just built these, so let me just rebuild quickly. You guys want to see? So I'll just pass to my script and it will build all the three binaries. And while it builds, let's go ahead. Basically, I was using these binaries itself, as you can see in my U-boot out folder earlier, to show you this demo. So it works. Just yeah, just take my word for it. I don't want to hold up on this. So yeah, let's go ahead. So yeah, next is TFTP. So now we've solved the boot binaries problem, which is tiboot3 tispl u-boot image. But what about your kernel image? If you want to, let's say, test something on the SD card specifically, you still need to run this UMS command every time and copy over your kernel image, your DTBs, everything over to the SD card. And it's still kind of painful. Like you still have to do an extra step, and writing to an SD card is slow. So if you are like me and are impatient and want a very quick debug build test loop, what you can do is set up a simple TFTP server on your machine. I've linked in the Arch wiki for it because I felt that the steps and the explanation was good. But if you just Google Ubuntu 22.4 TFTP, you will find similar steps. And it's a fairly straightforward service to set up. Probably just a single systemctl command and the server is up. And typically it's at SR with TFTP. So what you do is once you have the server set up, when you build your Linux kernel and your DTBs, all you do is you copy them over to this folder, and then this server is just set for anybody on your local network to fetch those files from that server. And U-boot supports loading files over TFTP. So instead of giving it a boot media like SD card or eMMC to load the kernel image and DTB like you usually do, what you can do is run these 3 commands. So, and of course, you need an Ethernet cable connected from your board to the local network where your PC is on. It could even be just a network on your desk. That's how I set it up, like a router between my PC and my boards. But it could also be the floor network. I don't know the policy there, so please check. But all you have to do then is set the server IP address in the uboot prompt and then do TFTP. This load ADDR variable is usually there in the default environment, and then say image, which is the file name of the kernel image. And similarly for the DTB files, you can do TFTP, FTT, ADDR, and name FTTT. So these two are also variables usually there in your default image. Otherwise, you'll have to look up what you want to do. And after that, you just hit boot and it works. So let's try these commands actually. So my local network has so I have 2 networks. One is the floor network, one is this local server where my PC is the main router. So this is the address. So let me do SETI and server IP. Let me just manually type it. And then do these 2 commands, TFTP, ADDR. So somehow something is broken here. Let me just do a quick reboot once. If it doesn't work, we'll skip. Yeah, looks like the basic DHCP isn't working. So we'll skip this one now, but just take my word for it that it works. Or let me just run this once again and not interrupt it. Maybe it works with the scripts I have and not working manually for some reason. Yeah, so it worked. So while it's loading, let me just scroll up and show what it did. So it basically set up this boot command to be DHCP set env server IP, load the kernel image, load the TTV, load all the overlays from my TFTP server, and then boot. So somehow the script is working manually. Maybe something I'm doing wrong, but I can show that these files are present. All my DTP, TTV, image, everything I built, I just copy it over here, and this is what it used to boot right here instead of the normal SD card images here. So you don't have to manually run these commands every time. You could either edit your U-boot environment, or there's something I'll talk about at the end of this, which helps you automate all of this, the scripts that I'm using. I can share that later with you. So this helped us solve the part of kernel images and DTBs. But what if you're like working on cameras like me and you have to, let's say, you captured some images on your SD card once you booted via this, and your root file system is still on your SD card. So once you captured some images, you either have to SCP over them, which is slow, or again mount your SD card and copy them over to the device. So wouldn't it be great if our root file system itself was living on our host and nothing was there on the SD card at all? So that is what you can do by setting up NFS. So NFS is network file system. And again, it's slightly more complex to set compared to TFTP, but the basic server should be similar. You just install a package and a systemctl command to enable the service. I've linked the Arch wiki again, but similar steps work for Ubuntu. I've tried them. And then what you have to do is there's something called etc exports, where you configure all the various directories or endpoints of your NFS server that you want to expose. So you can do this for each board because each board will have its own SDK, like image that you want, like its own root file system that you want, or you can share as well. I tend to, like, I used to keep them separate, but now I've realized that I can just share the same root file system across different EVMs and it just works. So what you have to do is just add this entry, like it first thing is where in your host you want to keep the files, the full root file system for your board. Next is IP address. Next, these are some parameters that I just copy pasted from the SDK documentation. I don't know what they do. You can probably look up the man page. And then just extract the root file system tarball in this directory, and you're good to go. So on the board now, if you want to use NFS instead of SD card or flash or some other thing as your root file system, while booting the kernel, you can specify the root equal to dev/nfs in the kernel arguments while booting, and you can do this via uboot. So in uboot, you can just set the boot as environment variable. I copy pasted all the other things that were already there in the variable and just replaced the MMC stuff with this NFS read write and the IP address of your host, the path, which would be SRVM62 for us, and these are the parameters. And this IP equal to DHCP is also needed so that your board can get IP address from the DHCP server on your network. Or you could even use a static IP for the board if you want, if you don't want to set up a DHCP server. So yeah, that is it. That is all that's needed. And when I ran my script, it actually booted via NFS. So this on the left of my screen, the file system you're seeing is actually neither the SD card nor the eMMC. All of those are mounted at some other mount points. And as you can see, there's no block device for the root file system. And if I do the message ref console to see the kernel command line, you can see that the root is dev nfs root, my PC's IP address. So it's fairly fast. You can, it helps like when I want to like update some scripts on my board or like copy some audio files or copy some camera images that I captured. All I need to do is do a simple copy paste on my host machine from this folder. I don't need to interact directly to my board at all. So this was NFS. Once you do all of the above, you're done. You don't need an SD card at all. You don't need to change boot pins. And there are a lot of steps here that you can script yourself. But I would highly recommend to check this next thing out, which is K3 boot switch. So this is one script which covers everything that we've talked about so far. And all you need to do is run a single command. You have to do some configuration first in a single file, but then all you need to do is run a single command. So it would be like DFU boot.sh. You just specify the name of your EVM, and through the config file, it automatically figures out which UART port is that EVM connected to, which relay is it connected to, what is the like DTB file or overlays that you want to send to that EVM. So all of this you can specify in your config file, and then you say what you want to do with that board. So you could say that I want to boot MMC device or eMMC, or you could say that I want to mount the SD card. So all you do is --mount one, and it will flash all the binaries over DFU, reach uboot prompt, and run that UMS command for you. All you need to do is give it the UART device in the config file, and it will write all those things over UART for you. You don't need to touch anything. Similarly, for TFTP, which means TFTP plus NFS boot, you just specify your server IP, and as long as your server is set and you've specified the correct directories in the config file, it will just boot. So I can show you an example config that I'm using to just give an example of how simple or how complex it looks. So this is the config file. So all I have here is code defines that to toggle power, I'm using USB relay. So this project already supports USB relay, fidget, a remote power switch that had a custom Python script that was just lying around, and I found in TI Bangalore office initially. So it can support multiple ways to toggle the power. And if you have some other way, I can actually show you the script itself. So it's just bash. If you have some other way, you can probably just Google these 3 ways that are already there and just add a new case for your personal way. It could be a Python script, some other command you run to toggle the power. And feel free to send patches or pull requests. And similarly, like we specify the IP address of the host here for TFTP and NFS, which is optional. You might not want to use it. And then we specify all the boards that you might plug in. So I have my USB relay only supports 2 switches. But I use 3 boards. So I toggle between 6.2 and 6.2p over one switch and 6.2 over the other switch. And you specify the UART devices for the boards, the NFS path of the file system, the DFU path. So if 2 boards are plugged in together and you run this DFU util command that we were talking about before, let me actually do that to show you the problem. So both my boards are reset now. So now if I do DFU util -L, I see 4 devices. And the only thing that distinguishes one from the other is this path, which is the USB controller path on my host. Like one is going through an extra hub, one is not. So this path is different. So while flashing, like if you just say bootloader, it won't know which bootloader, this one or this one. So you can basically just use this -P option in DFU util, which is the path, USB path. And the script already supports. So if you're using this script, all you need to do is specify this path once here, and you're done. It will automatically know which, when you want to boot 6.2, which DFU util -P option to pass. Similarly, you can specify overlays here as well. So you don't need to edit even with txt or uboot environment, because this script is basically sending commands over UART every time you boot. So you can just send the different overlay name in this list. And yeah, that is pretty much it from the configuration point. Now, coming back to the K3 boot switch. So a brief history of this repo. I did not write it myself. Mostly Nikhil Devshatwar, who was in TI a few years ago, was maintaining this host tools repository, which wasn't public back then, but recently I noticed that git.ti.com has this host tools present. So these have resource part statistics. These haven't been touched in like more than 2 years now, but this K3 boot switch, I still try to keep it updated with the new boards and new power toggling mechanisms. Yeah, all of this is public. If some customer is also interested in automating this for their own development, and internally, before I knew this was public, I was just maintaining an internal fork without the other folders, just the K3 boot switch on my Bitbucket. This has a better history if you're interested, but now I've moved development back to the host tools repository. So if you want to send a pull request or patches, send it to this first original repository. So this originally started for Jacinto boards, J7200 and J721E. Since then, all I've seen is 6465 and these Tara boards. If somebody in Jacinto team finds this useful, and if you want to like send packets for the newer J7 SoCs, feel free to do so. I'll be happy to review. Given we are doing good on time, I can slightly dive deeper into how exactly this script is doing all of this in case anybody is interested, or we can just go to Q&A. So yeah, this is where we are finally. Embedded development does not have to suck, and you can do all of these things without touching your board. Something that still sucks for me personally is changing camera sensors. I have not found a good solution that is not very expensive so far. So if somebody has any ideas, I'll be happy to know. But all the other things that we mentioned, the pain points, we can actually fix. So yeah, if floor is over to you guys if you want me to dive slightly deeper into the source code of DFU boot and how we do all of this. I can do that, or just basic Q&A.
Yeah, I have a couple of questions, Jay. For the USB device support in U-boot and the DFU, all of this support just the OTP port on the board, right? So there's only one port that can be used for this, just the USB-C port.
Yes, as far as I'm aware, on the SK-AM62 family of boards, that's the only port that can act like that. The other USB ports are for other peripherals like a mouse or keyboard you want to attach on your board. It cannot be SoC act as a peripheral. Yeah.
Okay. Do you have a situation where you need to plug in a USB device, like the USB camera, to it?
Yeah. So for now, the other USB port has worked fine for me because I have really needed USB 3 or USB-C like kind of a device. But if you do need that, then yes, it will be a problem. And I'm not sure if a USB hub will make it work. So yeah, that's a good problem. Yeah.
Okay, got it. And then from the point of view of setting the boot modes, are you aware of the Tiva-based test automation capabilities that we use in a test farm? Have you tried? So, I mean, it could be another way to approach the problem.
Yeah, good point. I'm aware of it. I've never personally used it, but we just found it easier on our personal desks to just, without the extra hardware, just set this up. But yeah, I guess with the automation header, things are much simpler. I don't know how hard it is to procure them, but yeah, that's an alternative as well.
Oh, well, I mean, in case of the most recent boards, you know, AHP and 6.2 boards, you know, AEN, these boards, we have implemented our test automation on the onboard Tiva microcontroller. So you don't even require an external hardware. All you need is to flash a firmware into that Tiva microcontroller, and you would be able to start using the XDS110 interface to do the test automation.
Oh, okay, that's pretty neat. Yeah, I wasn't aware that there was a Tiva microcontroller on the board.
Yeah, maybe Colton. Yeah, sorry, go ahead.
You just need to be, you're picking one of the two choices, right? Either you want to use JTAG, OpenOCD kind of function, or you're using it for debug.
Okay. Yeah, so I guess most developers want JTAG as well. So for test automation, it might make sense to drop that. Yeah.
Okay. Yeah, I think we were able to enable both, but yeah, that's something probably we can work together. Maybe at some point Colton can share, you know, how this stuff works, and you know, if anyone's interested, you can use it.
Yeah, sure. That sounds good.
What about the support for Jacinto devices? Is that also there in this boot switch?
Yeah, good question. So the J721 is the common processor board. Support for that is there. Let me just show. So basically, if you look at bin, so this has the 3 binaries with the DFU mode enabled, TFTP, SPL, and U-boot. So these are all the boards currently supported. And the boot select is, so this is something I didn't mention. Let me take a quick second. So when I was mentioning setting the def stat register, I mentioned that you can go to the U-boot prompt and run this command. But it's kind of slow to first flash 3 binaries over DFU and then set this register. Even in an automated way, it does work, but it's kind of slow. So what you can do, and this script, this project does, is it has a custom hack patch for U-boot. So let me open this up. So what this hack patch is doing is it's just going in the init function of your R5SPL and setting this register, and then setting the MCU domain bomb reset. So you can basically compile U-boot for various boot modes, compile the DFU3.bin binary for various boot modes, and then just flash that over DFU. So if you are in the DFU boot pin mode, which you should ideally be if you're using this project, and you want to switch to MMC or eMMC, all you need is this, need to compile this R5SPL binary, and the script, if you place it in this folder with spl.bootmode extension, the script will automatically pick that up and flash it as the first binary. And when you flash that binary and it executes, it will change the boot pins, change the tfstat, and reset the board. So it's very quick. I can actually show that.
So this spl.mmc, you are checking the MMC boot mode as the
Exactly. Yeah.
in the patch,
Yeah.
and we can make multiple ones by changing the patch again and again, something of that sort.
Exactly. Yeah. And I've committed the binaries for the MMC boot mode, but like all the other boot modes I didn't personally test, but they were working till some point, so I'm assuming they'll work now as well. So if you're interested in contributing, you can basically do the same thing for J7 boards and just build those binaries, test it, and send a PR, and then this project will support the J7 boards as well.
Okay, and what about that bin folder that you showed in the beginning? So boot
Yeah.
select is one folder and the bin folder is for?
Yeah, so boot select is for this patch binary is just the R5SPL, and the bin folder is the binaries for the DFU boot mode. So we want to keep we want to keep the board on DFU. So all the other U-boot commands that we're running, like TFTP, NFS, or UMS, we flash these three binaries over DFU. So you just place them in the folder and the script will pick it up.
Got it.
Yeah. Yeah, I wanted to show that MMC boot mode. Yeah, go ahead.
I have a couple of comments. First of all, this is really good. The DFU SOCID, that's new to me. I never looked into what it is. That I might look at it, and that might help me to do the DFU automation on my setup. But I have a couple of comments on the NFS setup. What I'm doing is on my setup, in the ETC export setup, I only give the for example, in your example, I only specify SRV. I don't specify AM62 here. So what I'm doing here is I have a folder, I have a multiple NFS file systems, but I don't specify the specific NFS. I specify the parent folder. So that means that I said there, I don't need to modify this file every time I have a new device added in.
Oh, okay. Yeah, that's very neat. I did not know that. So I can show you my ETC exports, which looks like this. So Beagle Plate, Debian, 62.
Yeah.
So what you're saying is you can just add an entry for SRV, and when booting the boot as you still specify SRV M62 in the NFS path, and it just works.
Yeah, exactly.
Okay, that's pretty neat. I'll edit the PPT to mention that actually. That will be useful. Yeah. Thank you.
And then second, in this export setup, if you add another parameter called a cross mount, CROSSMNT, in a bracket parameter, you add a cross mount. What it does is you realize that you have a problem. So for example, we work on multiple devices, multiple different SDK versions. So we have so many NFS file system on the PC. And then every time you make a kernel build, you install the kernel modules into that NFS. And then you have your own home folder, like you have your script, you're collecting data, you're testing. And the problem is you move from one NFS to another, that data doesn't move.
Yeah.
So what I have in my setup is I have a multiple NFS on my PC, but I only have one folder called the lib modules. And I have another folder called home root. And then on the PC, when you use a cross mount, you can mount your lib module folder and your home root folder to your NFS folder using the band mode mount.
Yeah, understood.
Yeah, so that means every time you switch to different NFS, your home folder is always there. You don't have a multiple copy of your home. You don't have a multiple copy of your kernel modules.
Yeah, that is very neat actually. Yeah, so I've actually faced that problem. Like if I look at lib modules in my AM62, it has a bunch of kernels and 62M has a bunch of different kernels. And sometimes I have to like reflash it again and again when I'm switching between boards. And same for the home folder. So yeah, I didn't know that was possible. So cross mount is what you mentioned, right?
Yeah, yes.
Okay, nice. Would you mind sharing your ETC export? I'll just add it in my slides as a good example because that seems to be much better than what I have here.
I can explain. I don't think I can do it here right now, right? I
Yeah,
can.
no worries. You can do it offline later. I'll add it to the PPT.
Yeah, I can send you offline on this. So the
Perfect. Yeah.
really nice part is on the leave modules, we can manage that. The good thing about this feature is you only have one copy of your home folder. You have your whole different set of scripts for the board, and you collecting data, you run different tests. So you only need one copy on the PC.
Yeah.
You don't have multiple copies in each NFS file system.
Yeah, that makes a lot of sense for home as well, and I guess even for LTP test cases, like while developing, I sometimes have to flash the OPT LTP directory on different boards separately, like just copy over these different. So even that, I guess we can cross mount. So yeah, that makes a lot of sense. Thanks, Will. Yeah.
Okay. Yeah, we'll talk offline.
Yeah.
One quick question. Can you go back into that 0x33 for the boot mode thingy?
This one?
Yeah. Is this information in public TRM?
Yes, I actually had opened the TRM to just this particular address. So this just that it's not very visible. Like I don't see how customer would figure out they have to do this. But
Okay, but does it give the different values? Like if you put this value, it doesn't, right?
No, and that was a pain point. So it just says the boot mode, and then you have to look up the boot mode pins. I forget where they were, and in there the order of the pins is slightly different. So you have to actually write the bits out and figure out the hex value you have to write to this register. It was a very painful process.
No, Nishan, this value is the same value as in the init chapter in the boot mode, sys boot mode. That's the same.
As you were saying, there's some bit order difference, something.
Yeah. I can show you the example actually. So MMCSD, let's try to find it. Yeah, so basically here we just say the pin mapping primary, like we describe how the boot pins are working and we give these examples for MMC. But if I just look at the MMCSD here, let's say MMCSD, so it says B3, B4, B5, B6. So out of all the bits, only these bits are listed. And then I have to know, like for let's say PLL config, what should be the config. So I know this is descriptive and good for the customer who's plugging in this SOC to their own board and want to do something specific on their board. But just for our case, it might be good to list the.
Okay, so the context of what I'm thinking is that why don't we give this as a U-boot command?
Oh, okay. Yeah, that would be actually very neat. Yeah.
Yeah, because this is
I'm
all
not
public
exactly-
information. So
I'm not exactly sure, but I think there is a Rome script which Rome folks have that give us these diff-start information. I think I'd seen it on someone else's PC. I don't recall well, but yeah, I think so. There exists something like that.
yeah, as long as the information is public domain. If not, we can ask our TRM team to make it public domain. We just need to help them with the documentation, and it is available across all the devices, right? We should enable that command because it's not just our boards, right? Even our SOM community boards or our customer boards, right?
Actually, PyTech already has a patch along that direction of exposing boot mode that we booted from, not from Alpha SPL towards A53 SPL and towards U-boot. I think we can, if somebody can review that patch and give a bit more constructive feedback, I think that'd be helpful. Yeah,
it sounds like this might be a common thing that will probably help our ecosystem a bit.
Nissan, do you mean instead of use the MW command modify the register directly, just use create a command but pass the value?
Yeah, human readable, right?
Yeah, makes sense.
Next reboot, EMMC.
Yeah,
right?
yeah. No,
I'm just randomly putting term there, but let's brainstorm maybe later.
No, Nissan really makes sense. I use it all the time.
I have a question on how this actually works. In a normal flow, this value on the register, I assume, is coming from the boot switches.
Yes.
So when you set this through the register, do you need to do something special not to overwrite it with stuff in the boot switches?
No,
Yeah, good
minus
question. So if you hard reset, this will not work. You have to use the reset command in U-boot or like press the button on the SK, which does the soft reset.
Soft reset. Okay. Okay, understood. All right, thank you.
Minas, this will probably help us debug those stupid boards like the Beagle AI64, which we can't do UR download, right? Because there's no boot mode pin
Yes.
for UR download. This will probably help us with that kind of crap.
Yeah, that's really good idea. Yeah, we could look into that. Mm-hmm.
Yeah.
This is also very helpful in the U-boot debug. You can put in a eMMC, doesn't matter where you put it. You put the default image, which is we know it works, and then you put it from there. You got to use the U-boot prompt, and then you can through whatever interface download the U-boot you try to debug, and then switch to that mode, and then do a warm reset. Next it will boot the debug U-boot code.
Yeah. That would be very interesting. There's a lot of potential around this thing if we can standardize the interface across the SOCs.
Yeah, I like the idea to make it a command instead of MW643 which remove the value.
Yeah, let's discuss that offline. As Vignesh was saying, FiTech guys have probably started on the same thread. Maybe we need to review the patch and then see how we can expand that overall concept.
By the way, with the soft reboot that we do from the U-boot prompt and like changing the boot modes, will we can we ever run into some issues with the DDI reinitialization not happening with soft reset or something? Like, can we miss some test case? I'm just curious on that regard. If you do it from like U-boot proper.
Yeah, it is possible because the soft reset is not a hard reset, like a POR reset. So there can be some sequencing that may have been missed, but it is so in terms of test coverage, you would have covered at least 98% of the scenarios with just the soft reset.
Okay.
That corner 2% like initialization, reset, hard reset, PMIC sequences, that kind of deal will probably be sitting on the side.
Okay, understood. Yeah.
Yeah, but for regression testing, for example, this would probably help us all throughout because like the PMIC behavior doesn't typically change once you've validated it. And that's the kind of corner cases that will stick around. So if you're doing first-time development, for example, on OSPI, you don't want to standardize on this, right? And if this is the only way you're doing OSPI first-time boot, debug, you have to validate it with physical boot mode switches. But from a regression testing perspective, this is very powerful because once we have proven that the hardware signaling is all good with OSPI boot, this is more or less what we want to ensure that we don't regress back.
Okay.
On this topic, I also didn't follow something. So if we want to use DFU in the worst case scenario where I'm away and my U-boot is corrupt and so I don't have access to the board, and so we're going to boot with DFU. I didn't follow how I'm changing the boot pins through software if U-boot's not functional. So that it boots in DFU next time.
John,
Yeah.
you set your board default to DFU. So every time you power the board, it's gonna do a DFU download.
Okay, so you have to always have it in DFU boot mode all the time to benefit from that. Okay.
Yes.
So that is one option. The second option is to mix these two, right? So you have a golden image that you're always having in eMMC, for example, and your board is set up to eMMC boot, but you run this MW command these guys are providing for DFU boot. So every time, so this is like automation testing, for example, with BeagleBoard. AI64 doesn't have a DFU boot option, right? Dip switch is not there. So you would boot out of eMMC every single time, then you would do a reset, but set it as DFU boot. And next thing you know, you have a DFU boot sequence started up. But if things go bad, physical power reset, you're back into eMMC boot.
Yeah, it's
It still
depending on
doesn't
what the
protect
mode
you against accidentally overwriting eMMC golden image itself. I think the solution there needs to be a wrong involvement. So unfortunate. That's the requirement we're putting on the next device.
Yeah,
Yeah,
that's why.
exactly. That's why the script was like recommends setting the DFU as default because you can mess up anything on your board, but if your board is on DFU, you can always flash.
Yeah, that's true. That's why DFU with a golden DFU image, that's the one can recover cases.
Thank you, guys. We are out of time.